post-vaccination antibody responses against SARS-CoV-2 in patients with liver cirrhosis. In reality, what we're going to talk about is what happens with our patients with liver cirrhosis in the era of COVID-19. Just a quick reminder, you all know the history behind the pandemic. The first case was at 8 December 2019. About 23 days after that, China reported to the WHO the first 27 cases of COVID-19. It took about 1 month to identify the cause of the agent, the new coronavirus. And then it took around 1 month and 5-6 days till we have the first patient outside China. And after that, things did not go that good. We have around 500 million cases since then, and more than 6 million people dying from COVID-19. So most of you had patients, and most of you know what happened with COVID-19. The vast majority of our patients are good. They stay at home, they don't have any problems. However, around 20% of them do present with severe illness. Fortunately, not in the Omicron variant, but that was the case in the previous variants. About 15% of them would come with low oxygen, less than 94% on room air, and about 5% of them would show with respiratory failure, we need to get intubated, and a lot of them will die. So the common question that we have in every hepatology department came mostly from cirrhotic patients who would come and ask, I am cirrhotic, what should I do? And in reality, in the beginning, we had no real answers. What we knew, however, was that SARS-CoV-2 likes the liver. We know that it uses ACE2 in order to get into the cell, and we know that cholangiocytes are cells that are very rich in ACE2 receptors. We also know that patients with cirrhosis have many more ACE2 receptors than patients with chronic liver diseases or normal patients or healthy people. And we also knew since the beginning that when we do a liver biopsy in a patient who has COVID-19, we will see microvascular thrombosis, we will see portal fibrosis, we will see many cells dying with apoptosis, we will have steatosis. So in the end, we were very concerned that patients with liver damage, with a chronic liver damage, with a chronic liver disease would end up dying. Moreover, we knew that patients with cirrhosis have a very defective immune response, both in bacteria and viral infections. They have damage of the hepatic reticuloendothelial system. They have a defect in hepatic protein synthesis. They have damage of the circulating immune cells. They have less B and T lymphocytes. Monocytes are upregulated, but neither of them works well. NK lymphocytes does not work well. They do have huge problems in destroying a virus or a bacteria. And that is why we do see them as immunodeficient patients. Moreover, as cirrhosis progresses, these patients have more and more systemic inflammation, and they get more and more immunodeficient. We do know that more than 10 years, and we know that these patients don't go well with infections. Moreover, we knew that the liver could get damaged by more than just the direct viral cytopathic effect. If I can just, there. So we do have SARS-CoV-2 that can damage mostly the cholangiocytes. We do have hypoxia-induced damage. These patients, especially those that need to get into the hospital, have low oxygen saturation, so you will get hypoxia in the liver. We know that microthrombi are usual in these patients, We also know that we have cellular ischemia, we have endothelial dysfunction. Moreover, many of these patients come with myocardial dysfunction, so that would add to a liver injury that already exists. And of course, most of the drugs that we use for COVID-19 are hepatotoxic. So drug-induced injury could lead to a deterioration of liver functionality. However, we do live in the 20th century, so we need to have data. So as soon as any patient with cirrhosis would come and ask, am I a high-risk patient? We would answer that most probably you are. However, we need to see data before we can say that. And we did have data. Within 1 year, we knew that these patients were high-risk patients. Here are the first 7 trials that we had. In 3 of them, we had more than 100 cirrhotic patients. In the one by Dr. Ioannou, we had 305 cirrhotics. The one from Kim, we had more than 200 cirrhotic patients, with almost 100 of them being decompensated. While in one study by Dr. Marjot, we have 386 cirrhotic patients. What did they all say? If you have cirrhosis, you have a high risk of getting into the hospital and dying. If you have a decompensated cirrhosis, that risk is even greater. So we need to be very careful with these patients. At some time, we also had another study that did not agree with that. We had a study that said that liver disease is not related with severe COVID-19. This is a very large study from Sweden. However, it has a few drawbacks, and that is that only patients with liver biopsy-proven liver disease were in the study. And that could be a problem because, as you realize, patients that have a rather decompensated disease they're not very easy to get a liver biopsy. Moreover, they had very few decompensated cirrhosis, and there can also be a selection bias if you only take patients with liver biopsy-proven liver disease. However, this was a very interesting study. It showed no difference between cirrhotics and non-cirrhotics when it comes to hospital admission and all-cause mortality. And it made us think that maybe we were wrong. However, I think that nowadays we will all tell you that cirrhotics are at a huge risk of dying when getting COVID-19. And this study here was the one that made us confident about saying that. This is a huge study. It has almost 9,000 patients with cirrhosis and COVID-19. It has almost 54,000 patients with cirrhosis testing negative for COVID-19 and 30,000 people without cirrhosis testing positive for COVID-19. And as you can see, having both cirrhosis and COVID-19 leads to a much greater risk of dying even at day 30, at the first month after SARS-CoV-2 infection, up to 3 months later. This is quite shocking if you look at it. This is a meta-analysis made by Dr. Marjot, and it shows that if you have Child-Pugh C, that means that you are very decompensated and that you have a liver that doesn't work, and you get into the ICU, you have an 80% chance of dying. Even if you get hospitalized for COVID-19, you have a 54% of dying. And if you need invasive ventilation, if you get intubated, you need invasive ventilation, then that risk goes up to 90%. And this is quite shocking, to be honest. Maybe it is a little bit exaggerating, but it is close to truth. If you have a patient who is cirrhotic, is decompensated, with a Child-Pugh C, and needs invasive ventilation, odds are that he will not get out of the hospital alive. So our answer to that question if cirrhosis is the predisposing factor for severe COVID-19 would be yes, especially when you're decompensated. So a lot of our patients, as soon as we knew that, would ask us, okay, so what do I do? Do I wait for death to come and get me? Do I just sit home and do nothing? In the beginning, we had no answers. We would say, be extra careful. Thank God, about 1 year after the first COVID-19 patient, we had the vaccines. Here are the first 2 mRNA vaccines, the first 2 publications, December 31st and February 4th, at the end of 2020 and the beginning of 2021. This is very interesting. This was one of the best news that we've had for years. This is from New York Times. They have something called coronavirus vaccine tracker that is constantly renewed. And we see right now that we have 12 vaccines approved for full use. We have 19 vaccines in early or limited use. And we have almost 40 vaccines that are in a large-scale efficacy tests. To make a long story short, we have 4 different kinds of COVID-19 vaccines. We have the mRNA vaccines. We have the virus vector vaccines, the one from AstraZeneca, the one from Johnson & Johnson, or the Sputnik 5 vaccine. We have the inactivated vaccines, mostly used in Asia. And we have the newer protein vaccines, like the one from Novavax that is used in the US. I don't know if it's gonna go well or not. Anyways, so we have the mRNA vaccines. They use genetically engineered RNA or DNA to generate a protein that safely promotes an immune response. We have the viral vector, the adenovirus vaccines, like the one from AstraZeneca, that use the virus that has been genetically engineered so that it cannot cause disease, but produce coronavirus proteins to generate an immune response. We have the inactivated virus, the whole genome virus vaccine that use the form that has been inactivated or weakened so that it does not cause disease but generates an immune response. And we have the protein subunit vaccines. They use harmless fragments of protein or protein cells that mimic SARS-CoV-2 to safely generate an immune response. So we do have the vaccines. The vaccines are safe and effective. However, the question has always been, is it for all? It is safe and effective. We know that for all healthy volunteers. What about liver patients? And the problem is that we don't have, at least at that time, we didn't have any data for that. And the reason was that these vaccines wanted to get an approval as soon as possible. And you do realize that having patients with cirrhosis could lead to a delay, could lead to patients having many side effects. So these are from the 2 mRNA vaccines, see that they have very few patients. So once again, we have no answer. And we have questions. What about the antibody levels? Will my patients get protected? What about safety? The first question is, why do we care about antibody levels? We would care because our experience with cirrhotic patients regarding antibody levels of various vaccines is not good. Think that in influenza vaccination, for example, we get seroconversion rate of less than 80%, especially for the H1N1 variant. From the pneumococcal vaccination, we get a little better through the seroconversion rates. However, we have a rapid waning of immunity. Same thing to HPV vaccination, even though we get quite good seroconversion rates, up to 79%. I will remind you that in healthy population, we have more than 90%. However, we have a rapid immunity waning. Same thing with hepatitis A vaccination, especially in patients with progressed liver disease. Patients with Child-Pugh with decompensated disease get only 55%, while patients with chronic liver disease and no liver decompensation get more than 90% of seroconversion rates. What about mRNA vaccines then? I did tell you that mainly what we do today are inactivated and mRNA vaccines. mRNA vaccines are mostly used in Europe, while inactivated are mostly used in Asia. So let's see the data about the inactivated, the mRNA vaccines. This is the first study ever made. 79 patients with cirrhosis, mostly non-alcoholic fatty liver disease and autoimmune diseases. Almost 30% had viral hepatitis. Only 10 patients decompensated, and the other groups would be liver transplanted patients and patients with chronic liver disease with no cirrhosis. The vast majority had used mRNA vaccines. They saw poor antibody responses in almost 23% of the cirrhotic patients. They had no impact on multivariable analysis, however. What was the drawback of this study? They only used IgG antibodies, they had no neutralizing activity measured, and they had no T memory cells. So we didn't know, according to this study, that patients with cirrhosis would get good IgG antibodies, but we didn't know if they would be helpful. We had no data regarding what happens next if these patients get breakthrough infections or not. And we have no data regarding the neutralizing activity of these antibodies. Another study, very helpful, with 89 pre-liver transplantation patients, that means patients that are cirrhotic, and most of them had a rather progressed cirrhosis. The median MELD score was 12. I will remind you that MELD score is a score that we usually use in patients that are going to get a liver transplantation, and patients that are less than 10 don't need to get transplanted, while those that have a MELD score more than 35 are those that are too sick to get transplanted. So what they found, they had 32% of the patients had viral hepatitis. We had mostly, almost exclusively mRNA vaccines, mostly Pfizer vaccines. They saw IgG antibodies at 1 and 2 months post-vaccination. They had no side effects. They had rather good seroconversion. However, they didn't see blocking activity, they didn't see neutralizing activity or T memory cells. What is important with that study is that they followed up the patients almost for 2 months, for 4 months, and they saw no breakthrough infections, which means that the mRNA vaccines most probably are safe and help against COVID-19 infection, against COVID-19. Another study with only 38 patients with cirrhosis, mostly autoimmune patients, around 24% of them had non-alcoholic fatty liver disease and 1/5 of them had viral hepatitis, mostly child QA, which means that they had cirrhosis but was a compensated cirrhosis. This is the first study that sees neutralizing activity, and they see that 1 month after the second vaccine, they had very good neutralizing activity. They saw that being a cirrhotic had no impact on multivariable analysis. We had no adverse effects. However, in this study, no T memory cells were assessed. On the contrary, T memory cells were assessed in this study. B memory cells were assessed in this study. And what they saw in only 48 patients with cirrhosis, mostly alcoholic liver disease in these patients. Most of these patients were compensated, and they saw that they had an impaired T and B cell responses, which was worse according to child Q stage. And that means that if you have a worse cirrhosis, a child QB or a child QC cirrhosis, then odds are that you won't get good enough T and B cell responses. A larger study with 110 patients with cirrhosis, mostly alcoholic liver disease and autoimmune, mostly once again child QA patients. However, this had also 30 patients with child QB cirrhosis. Good antibody responses. However, what the author saw that 16 weeks after the second shot, we had a rapid waning of antibodies. However, in this study, we have no T memory cells. Same thing here, they had No differences, however, only 46 of cirrhotics had good response to the vaccines. And what about inactivated vaccines? Mostly the results are the same. You have a good seropositivity for IgG. You have here worse results when it comes to neutralizing activity. However, you have a waning humoral immune response. You have low levels of B memory cells. You have a rapid waning of antibody levels, especially when decompensated, especially when you're very sick. This is another very large study, which has 153 patients with cirrhosis, with 30 patients decompensated. And they had as other groups 284 chronic liver disease patients with no cirrhosis and 144 healthy controls. All patients used inactivated vaccines. They had lower levels of seropositivity of neutralizing antibodies in chronic liver disease patients. However, they had no differences between compensated and decompensated cirrhotic. However, this has a very short follow-up and a low number of decompensated patients. However, this also shows that being liver disease is a bad factor for your antibodies. Same thing here, huge study, 388 compensated patients with 165 decompensated. This is mainly hepatitis B chronic liver disease patients. They use inactivated COVID-19 vaccines. As you see, the mRNA vaccines mostly use non-alcoholic fatty liver disease or autoimmune patients, while on the contrary, those that use inactivated vaccines mostly use patients with chronic hepatitis B. They come mostly from Asia, and hepatitis B has a higher seroprevalence there. What they had no significant side effects. They have a 70% seropositivity rate for blocking antibodies. In this study, there are no healthy controls. However, we do know that seroconversion is about 70 to 90% in healthy individuals. And once more, they had lower rates in child QB and child QC patients, as you see here. So if we had to sum up, we would say that patients with cirrhosis do show adequate responses when it comes to IgG and most probably also to neutralizing activity in the first month. We do know that vaccines against cirrhosis, against SARS-CoV-2 are safe in patients with cirrhosis. However, we did have a rapid loss of antibodies. We did have a rapid waning of antibody responses. So it is good to have studies. But in real life, we have to do with patients, not with numbers. So our question would be, okay, I will take my patient to do the vaccine. It is safe. It will probably help him for a little while, but is he really protected? Look at this study. I think that this study made us certain of ourselves and made us say to our patients that get vaccinated and you won't have a serious problem. 20,000 people with cirrhosis getting at least one dose of mRNA vaccination, 42% of them had alcoholic liver disease. That is very interesting because alcohol per se leads to immunodeficiency, leads to patients who cannot mount enough responses to vaccination. 12,000 people of them received 2 doses. Most of them were child QA patients, but 15% of them were child QB. That is not a very high proportion, but if you get to 20,000 people, you understand that there are a lot of people. They had median MELD score 8, quite low. And what did the authors show? You had a 64.8% reduction in COVID-19 infections 20 days after the first dose, 50% reduction when your patient was decompensated, and only 7 days after the second dose, we had 78.6% reduction in COVID-19 infection, which is huge. In multivariable analysis, around 25% reduction in COVID-19 infection of death. And what is even more interesting is that we had no statistically significant differences in decompensated cirrhosis in patients with SARS-CoV-2 B and C. And of course, we had no serious adverse effects. The largest ever study, almost 7 million patients, vaccinated mostly with AstraZeneca vaccines and then with mRNA vaccines. The median follow-up time was around 1 month after the second dose. Among them were 17,000 patients with cirrhosis, and look at that, only 27 patients with cirrhosis died, and 19 patients needed to get to the hospital and got out well. The only problem with that study is that it has only 1 month of follow-up. However, you can see here that in liver cirrhosis patients are at high risk. They are high-risk patients. Even after vaccination, you get much better results of the vaccination. You get only a few patients that die or get hospitalized, especially at 1 month after vaccination. However, you get worse results than having severe combined immunodeficiency. You have the same results as having HIV. And the only patients that, even if they got vaccinated, they would get to the hospital more are patients who would get grade B or grade C chemotherapy and patients with Down syndrome. So you see that, according to this study, there's no question if you should or should not vaccinate your patient, and there is also no question about if your patients are at high risk anyway. So even if you get vaccinated and you are cirrhotic, you need to be careful. These were mainly non-whole virion vaccines. Is it the same for inactivated vaccines? It is exactly the same. People that would get vaccinated, especially when they get 2 doses, they would get much better absolute reduction when it comes to getting into the hospital or dying. The main vaccine here was used was Mrna Vaccines. Same thing here, 3,000 patients that were unvaccinated versus 254 post-vaccinated cirrhotics with propensity match cohort. That would get 254 vaccinated and 508 unvaccinated, which is 1 to 2, mostly mRNA vaccines. 1/5 of them would be decompensated patients. Around half of them would be of alcoholic liver disease. The median time vaccination disease will be 27 days. And see what happens here. Post-vaccination, you have only 9 patients with only 7 COVID-19 related deaths. See the results from the unvaccinated cohort. And the same thing for mechanical ventilation. We do know that patients that have cirrhosis and get to the hospital and reach mechanical ventilation, we saw that we knew that from the end of 2021, they will die. We know that patients with cirrhosis that get into the hospital will not die from liver disease, but will die more easily than everyone else. So getting vaccinated is very helpful. It's the efficacy is high and the safety is high. So to make a long story short, we need to have some take-home messages. We know that COVID-19 vaccines are safe. We know that they are efficient in cirrhotic patients. We know that they will protect you from the need for medical ventilation and COVID-19 related death. However, we also know that patients with cirrhosis have a rapid waning of their antibody levels, and that makes at least 1 booster dose mandatory. There is a huge question how many doses we will have. There is a huge question how often we will have that. We need large studies to show us what happens after 5 months or 6 months. We know that healthy individuals don't have good antibody responses 6-7 months after getting vaccinated. So the question is, we will have cirrhotic patients getting vaccinated every 6 months. We will have them getting vaccinated every 1 year. What is the cost efficiency for that? What we also do not know is if there is a difference between vaccine types. What we have up till now, I would say that most probably mRNA vaccines are a little better than the whole virion vaccines. However, we definitely need much more data for that. And all the data that I have shown you is about the alpha, mostly alpha, beta, and delta variants. We have in reality we don't know anything about the Omicron variants. We have no study about the Omicron variants. What we know from clinical practice is that your chance to die when you get Omicron or even to get to the hospital is much, much lower than we have in alpha, beta, and delta. However, we have no data on cirrhosis. So that is something that maybe we should really talk about a little bit more. And with that, I will thank you for having the opportunity to present you all the data regarding the cirrhotic patients and the COVID-19 infection.